All right, we're going to be doing a practice for Chapter 2. This is meant for informal geometry, but could be used for other classes as well. The first two problems here, we're supposed to underline the hypothesis once and the conclusion twice. After that, you're supposed to write the converse of that statement, which is found by switching the hypothesis and conclusion. So the first statement, if you are an armadillo, you are an armadillo would be your hypothesis, and you are a mammal would be the conclusion. Whatever follows the if is the hypothesis. Whatever follows the then is the conclusion. Now, to write the converse of the statement, we would keep our if and then in the same place and switch the hypothesis and conclusion. So we would start with if you are a mammal, then you are an armadillo. Okay, and the second statement says, if two segments are congruent, then they have equal measures. So our hypothesis, two segments are congruent. Our conclusion, they have equal measure. If we wanted to write the converse of this statement, again, the if and then stay where they are, and we switch hypothesis and conclusion. Now, it wouldn't make sense to start with the pronoun they, so we would say, if two segments have equal measure, then they are congruent. And then we would be finished doing our converse. The next section here asks you to justify each statement with a property from algebra or geometry. So taking a look at this first one, says if x minus y equals 17, then x equals 17 plus y. Well, if you look here, we added y to both sides of this equation to get what we have over here. So that would be the addition property of equality. That's our abbreviation for addition property of equality. So I have some technical difficulties with letters disappearing here. Our second one, AB equals AB. Anytime we say two things are equal to each other, we think of reflection. So it's the reflexive property of equality. And our next one, number 5, says if x plus 8 equals 22, then x equals 14. To solve this, you needed to subtract 8 from both sides. So we're looking at subtraction property of equality. Again, this is a property of equality. The next one, if 6 equals x, then x equals 6. This is switching the sides of the equal sign that two things are on. So we're going to say symmetric property of equality. And I apologize if anything is looking a little funky here. We're having a little bit of computer slowness. The next one, if W is between Q and S, then QW plus WS equals QS. Well, for number 7 here, we need to kind of picture something here because W, Q, and S are going to be points. So if we were to picture this, we would have Q and S, and W is between them, meaning W lies on the line that connects the two. Now these two segments here don't have to be equal, so it's nothing to do with midpoints, but we're saying that QW, this segment here, plus WS, that segment here, is equal to the whole thing QS, and that's segment addition. Postulate. Okay, the next one says if AB equals CD and CD equals EF, then AB equals EF. Now what we're looking at here is both of these are equal to CD. So that means the two things equal to CD, AB and EF, must be equal, and that's our transitive property. And this again is a property of equality, like many before it. Next we have something very important. M is the midpoint of segment AB, should be segment AB here. Then AM is equal to 1/2 AB. Now we said if we were to tell that two halves are equal, that would be the definition of midpoint. If we're saying that the whole thing is twice as big as one of the halves, then that's the midpoint theorem. Okay, key being the word midpoint there. Number 10, if 3p equals 27, then p equals 9. Most people would know that to solve this problem, we divide by 3 on both sides and we get p equals 9, so that's division, property of equality. And that is the end of this section. Okay, the next section here, we have a proof that we need to fill in the blanks for, and it says given angle 3 is equal to angle 4, so I'm going to go ahead and mark angle 3 and angle 4 equal. And it also says that angle 1 and 2 are the same, so 1 and 2. And this is very similar to one of the problems we've done in class for our examples. The next thing you want to do is look at your proof. You're trying to prove that STU and DUT are congruent. STU and DUT are congruent, so you want to prove that those big angles are congruent. Now, if you see the lines disappearing here, they should be back in just a moment once our computer gets done thinking. So let's take a look. Step 1 claims that angle 3 and angle 4 have equal measures. Well, we already said that that was true in our given statement, so we know that this is part of our given, as well as angle 1 being equal to angle 2. Okay, those two things were already given. Okay, so given. Step 2 shows us that angle 3 plus angle 1 is equal to angle 4 plus angle 2, and that's these two added together equals these two added together. Well, if you were to look at this without seeing the picture, you would see that you have an equation, angle 3 equals angle 4. We added angle 1 to this side and angle 2 to this side, so it's addition, property of equality. Now the next step, the reason is given to us over here. It says angle addition postulate. Now angle addition postulate says that we have small pieces added up to equal a larger angle. So looking back at the picture here, we only have two options, and since we have two lines that we need to fill in, I'm probably going to be looking at this big angle and this big angle, since they're the ones that I'm looking to prove something about. So I'm going to go ahead and say that over here, angle 3 right here and angle 1 right here add up to angle STU. So we'll say that over here, measure of angle 3 plus the measure of angle 1 equals the measure of angle STU. We also know that up on the other side that angle 4 plus angle 2 equals the measure of angle DUT. Now to get to the next step, this problem all of a sudden ends up with what we were trying to prove in the first place. That means we're done on this step. But how did we get STU and DUT equal? Well, we had STU was equal to this right here, and we had DUT was equal to this right here. But if you look, we had this green, measure of angle 3 plus measure of angle 1, in step 2 is equal to measure of angle 4 plus the measure of angle 2. So looking at step 2, measure of angle 3 plus the measure of angle 1 equals the measure of angle 4 plus the measure of angle 2. We replace this with STU, and we replace this with DUT. Now, of course, these are the measures of the angles, and that's how we get to the end. So the reason we were able to say this is by a simple substitution. Now, I know it looks kind of crazy now, but you could always rewind and take a look at that again if you needed to. The next section here deals with protractors, and we have some protractors, and we're told to find the measure that is paired with the angle. So if you take a look at this first one, we have a protractor 180 degrees over here, 0 degrees over here. So obviously the 40 and the 108 fall between those. But what's important to know is that this bisector, since this is a bisector, we know that this angle and this angle should be the same. Okay? So that means whatever amount we get here, we need to add to 40 degrees to get up here. So if we take 108 and subtract 40, we would get 68 degrees. So we have a 68-degree angle for this whole angle. So half of that, going from this part right here, is going to be 34 degrees. So 40 plus 34 brings us to 78. No, 74. Whoa. Looking at the other numbers there. Let's just start that over again so you can read that nicely. Another way to do this one is to just take these two numbers, the 108 and the 40. I'll just clear all this out. A nice shortcut for these kind of problems is just take 40 and 108 and average them together. If we add these two, we get 148. All we have to do is divide by 2 since we're averaging two things together, and we get 74 degrees. Over here, this one would work the same way. 71 plus 165. We do 165 plus 71. We get 236. All we need to do is divide this by 2, and we get 118 degrees. And that's the measurement that is paired with this angle bisector, since these two are equal. And that is how we do those problems. The next few here ask you to find the value of the variables. There may be more than one. The first one, for example, we have p's and we have w's, so it's going to be a challenge. Now, the first thing we should look at is that we have two intersecting lines for this one. So we know that vertical angles, these two, are congruent. So 2w is equal to 132 degrees. We can divide by 2 on both sides and get w equals 66. And that would give us a nice solution here. We also know that we have vertical angles right here. This angle and this angle, they should be equal. So 4p is equal to 3p plus 12. If we subtract 3p from both sides, using our subtraction property of equality, we get p equals 12. And that's how we would solve it. The next problem, a little bit trickier. We have, instead of setting vertical angles equal to each other, that would give us two variables, so that's not going to help us much. But we also have a problem here with these vertical angles because they have two variables, so that won't help us much. However, if we look down here, we have this angle plus this angle here are going to make a straight angle, which is 180 degrees. That's for their sum. So to solve this problem, since these two both have y's in them, I'm going to add them together and set it equal to 180 degrees. Combine like terms and add 20 to both sides, and we'll get 8y equals 200. And of course divide by 8. I'm running out of space here, but you can all see here that we get 25 for our answer. Just want to make sure that's right. So y is 25. And that only gives one of the values. So how are we going to find x in this mystery? I'm just going to clear some of this out. Put my 25 back in for y. We know y is 25. So what I can do is I can plug y, 25, in for y anywhere I want. I'm going to put it in right there. So I'm going to say 3 times 25 minus 13 is this angle right here. Okay, that's 75 minus 13, which is 62. So this 62-degree angle is equal to the vertical angle. It's vertical angle right here. So 5x plus 12 equals 62. And we subtract 12 from both sides using subtraction property of equality. 5x equals 50, so x is 10, using division property of equality. So we get x is 10. And that is how we would solve that. This next problem here pretty cut and dry. We have two vertical angles that are equal, so z minus 11 equals 3z minus 73. And when we go to solve, all we have to do is make sure we get our z's together. So we got to subtract z from both sides, which gives us negative 11 equals 2z minus 73. Now if we look over here, I'm going to add 73 to both sides and get 62 equals 2z. If we divide by 2 on both sides, we get, using division property of equality, we get 31 is our value for z. So z is 31. Remember that symmetric property says we can switch sides of the equal sign. And last but not least, number 17 in this section says 4n plus 5 and 9n minus 45 are vertical angles, so we should set those equal to each other. Sorry if these things keep disappearing. We have n's on both sides, so we're going to subtract 4n from both sides, giving us 5 equals 5n minus 145. And all we have to do is add 145 to both sides to get 150 equals 5n. And that gives us 30 for n. Okay. And then to find d, of course, these two values are going to be equal to each other. I'm just going to solve it a little bit lower here, right underneath d. We'll say 12d minus 5 equals 6d plus 25. And we subtract 60 from both sides, which gives us 60 minus 5 equals 25. And then we add 5 to both sides, 60 equals 30. And of course, divide by 6. So d is 5. And that is how we would solve that problem. One more section to go, and then we are done. This last section has a lot of lines in it, and one of the things we have to do is be able to ignore what information we don't need and pay attention to what information we do. Now, it's important to read the directions. It says GI is perpendicular to BH. So we're going to go ahead and I'm going to highlight BH and GI. Those are perpendicular, meaning they intersect at 90-degree angles here. And EOH is 60 degrees, which is marked for you right here, 60. Okay, and I'll label that angle in red. Okay, that's a 60-degree angle. The first thing you're supposed to find is the measure of angle IOE. Well, let's take a look. If we go from I to O to E, we see that this angle right here plus the 60-degree angle should make 90. They're actually complementary angles. So we know 90 minus 60 is 30 degrees. That first one's done. Number 19, measure of angle BOD. We go BOD. That angle right there is actually a vertical angle with the 60-degree angle. So this must also be 60. Sorry if the computer's being slow again. Number 20. We want measure of angle BOE. So if we start at B, we go B, O, E. Now this big angle, that consists of a 90-degree angle here plus this 30-degree angle that we found before. So it makes 120 degrees for BOE. And we're just going to clear everything out. Start fresh here for number 21, the last one. The measure of angle AOI is 64. So if we go AOI, if this were 64, then what would FOH need to be? And we'll mark FOH, FOH. What would this angle need to be? Now what we can say is that since we have a straight line right here, is that we know that all of these angles are going to add up to 180 degrees. Now this is one way to solve it. We could say all these make 180 degrees. So we know that originally we were told GI and BH are perpendicular. So GI and BH are perpendicular. So that's 90 degrees, 90 degrees, We could make 180 degrees going across and use this angle right here also being x. We could do 180 going across here. We could also solve the problem using that these two add up to 90 or these two add up to 90, or that these two add up to 90. There's so many options here, I think that's getting confusing. Let's just redraw here. We're told that for number 21 that this angle is 64, AOI is 64, and we want to find this. I think the easiest way is to use our vertical angles. And then remember that these two lines are perpendicular. So what is the relationship between 64 and x? If these green lines are perpendicular, they add up to 90 degrees. That's probably the easiest way to come up with the answer. So we'll say 90 minus 64 is going to be 26, and that'll be the measure of angle FOH.